All right, last section of the unit. This is 4.8, and we always come back to functions. So we're going to try to expand our understanding of functions today in a couple of different aspects. So there's going to be a lot of little items in this section. Nothing that's too particularly hard, but it will increase your understanding of exactly what a function is and how it's going to appear on the coordinate plane. So just remember that a function is a relation in which each input has one and only one output. And you'll remember this from a previous lesson. Here we have an example of something that is a function. When you plug in a 0, it only spits out a 5. It never spits out anything else. When you plug in a 1, it only spits out a 7. It never spits out anything else. When you plug in a 3, it only spits out a 32. It never spits out anything else. So remember, a function has to do with input and output, and each input has one unique output. All right, these are things that are not a function. So this is a representation of something that would not be a function. And if you'll remember, which input value here is kind of screwing that up for the others, right? Well, it's the 1. Sometimes you plug in a 1 and it spits out a 6. Sometimes you plug in a 1 and it spits out an 8. That's possible. We just don't call it a function, okay? All right, well, one of the ways of determining a function is not just by looking at an input-output table, but you can also tell by looking at the graph. And we do something called the vertical line test, okay? So the rule for the vertical line test says a relation is a function if and only if no vertical line passes through 2 or more points on the graph. And I'll show you what I'm talking about here. Okay, so here we have a graph in black, okay? And this is a function because if I start drawing a vertical line at any point along this graph, how many places does it intersect the graph in? Okay, and if you take a look at that red dotted line, think of it as an invisible line, how many places, in how many places does it touch the black graph? Okay, and the answer is 1. Okay, 1 and only 1. Okay, if I were to draw that red line anywhere else to the left or right, it's just going to impact it in one location. It's just going to intersect it once. Okay, contrast that with this guy. Okay, this guy's not a function. Okay, and one of the ways I know that he's not a function is because he fails the vertical line test. The guy on the left passes it, but the guy on the right definitely fails it. And let's talk about why. Okay, with the first guy, for this vertical line, there was only one point of intersection, right? If I had drawn a line somewhere else, like over here, it just crosses one time in one place. Okay, over here we have an example where a vertical line crosses this graph in 3 separate locations. Okay, and that's going to indicate that one input has multiple outputs. Okay, for example, let's come back to the first guy that is a function, and let's focus on this point right here. Okay, that point is technically 3, comma, negative 3. In other words, when I come over here and plug in a 3, it spits out a negative 3. Okay, or if you were to look at this guy right here, okay, for that guy, when I plug in a negative 3, it looks like it spits out a 1. Okay, so for each input, there's only one output. But the graph on the right, if you look here, I'm plugging in a 4. Okay, and sometimes that 4 spits out a negative 3. Sometimes that 4 spits out a negative 7. And sometimes that 4 spits out what looks to be like a 6.5. Okay, so that input 4 has 3 different outputs. It's possible, but it's just not a function. Okay, and if I were to write the t-chart on that, right, for the input and output, you'd see 4, negative 3, 4, negative 7, and then 4, positive 6.5. And you would know, okay, that guy's definitely not a function. Okay, now, usually on these input-output tables, we've been writing input-output or x, y. Today we're going to get more into function notation. So the input is still the x, but the output is what we call f of x. And we did bring this up in an earlier unit. Remember that f of x, it refers to functions, and it means the value of the function at x. Okay, so when I plug in a 4, okay, the value of the function at 4 here is -3. Or sometimes the value of the function at 4 is -7. Or sometimes the value of the function at 4 is 6.5. It all depends. Okay? So just remember, it could be x comma y, it could be input output, it can also be x comma f of x. All right, so that's the vertical line test. I just brought up function notation. Let's review that again. To put an equation in function notation, generally replace y with f of x. It is read as the value of f at x, or simply f of x. Okay, this is the first thing that you're going to need to do on paper. All right, so go ahead and take out your paper, and I want you to write down this function. Go ahead and write down f of x equals 7 minus 3x. I'll give you a chance to do that. Remember, this is very similar to saying y equals 7 minus 3x. Okay? But when we're talking about functions, we'll use the notation f of x. Okay, and they want you to evaluate that for when x equals 4. Okay, so what they're really trying to do here is they're trying to get you to find f of 4. So remember, you're going to plug that 4 in for the x. So on your next line, I want you to write f of 4 equals 7 minus 3 times 4. Okay, so when we're evaluating the function for 4, we're really just plugging that 4 in. And remember that f of 4, that does not mean f times 4. It just means the value of the function at 4. Okay, so when you plug in a 4, what is it going to spit out? Well, that's what the stuff on the right tells you. So what is 7 minus 3 times 4? Okay, there you just have to do order of operations. It's going to be 7 minus 12, and that's -5. Okay, so f of 4 equals -5. The value of the function at 4 is -5. And that's the point, 4 comma -5. So if you were to plot that, you'd go over 4 to the right, and then you'd go down 5. It's the same thing as x comma y, 4 comma -5, or in this case, x comma f of x. All right, try this one on your own. I want you to write this down. G of x equals 10x plus 3. Go ahead and tell me what g of -2 would equal. And I'll just give you a 5-second head start on that. All right, well, g of -2 is going to be 10 times -2 plus 3. And so really you just have to know how to evaluate something here. Okay, so what is 10 times -2 plus 3? Make sure you do your order of operations. That's going to be -20 plus 3. Looks like g of -2 is going to be -17. And so I just want to re-emphasize here that when we're talking about functions, for ordered pairs, we are used to x comma y, but when we're dealing with functions, we're going to think of it as x comma f of x. Okay, so for the first one, the ordered pair we could write would be 4 comma -5. You plug in a 4, and it spits out a -5. For g of -2, the ordered pair would be you plug in a -2, and it spits out a -17. And that means on the graph, when you go over to -2, you're going to go down -17. You won't go anywhere else because for each input, there's only one output. Okay. We'll come back to that at the end and give you some more practice with that. You do not need to do any work here. I just want you to listen really quickly. When we graph functions, we do the exact same thing that we do with slope-intercept form and y equals mx plus b. Okay, so instead of seeing a y equals situation, you're just going to replace y with f of x, and you'll have function notation. So you can graph something that looks like this. F of x equals -2x plus 3. It's just like it's in slope-intercept form. Okay, where would you start? Well, what's your y-intercept? Your y-intercept is at +3. So your first point would be at +3, and then your slope is at is -2. So think of that as -2 over 1. You're going to go down 2 over 1, down 2 over 1, and you'd connect to make your line just like you would with y equals mx plus b. So just know that with function notation, you're going to use f of x instead of y. Okay. All right, so now it's time to practice. We're going to spend more time practicing. I'm pretty much done lecturing. example 1, so go ahead and label your paper. And it doesn't matter tonight if you have graph paper or regular paper. Either one is really fine. And for example 1, what I'm going to want you to do is draw 6 quick coordinate planes. And I'm actually going to do this with you. So we're going to kind of work together on this lesson. So you really can just draw a simple x-axis and then y-axis, and that will suffice. And you're going to do 6 of these. So for me, it's going to be 3 on top, 3 on bottom. On your sheet of paper, it doesn't matter to me how you do it. You just might want to leave a little bit of room in between the top and bottom of each one. And they don't need to be perfect, but they should be nice. And then I want you to number each one of these. And at the bottom, you're going to draw a little blank, and that's basically going to be your answer blank. So once I have this all set up, and once you have it all set up, we're going to draw a graph, and you'll copy the graph that I draw, and we're going to try to determine whether or not it is a function. If it is a function, you're going to write yes in the blank. And if it's not a function, you'll write no in the blank. Pretty simple. Okay, hopefully you have everything set up by now. I figure you probably should be quicker with a pencil than I am with my stylus. If not, you can hit pause until you are ready. But here's what's going to happen. I'm going to draw 6 graphs. First thing I want you to do is copy the graphs to the best of your ability. Okay, and then I want you to think about whether or not each one is a function. But let's draw the graphs first. Okay, so number 1 is going to look something like this. Number 2 looks something like this. Number 3 is going to look something like this. Number 4 looks something like this. Number 5 looks something like that. And then number 6, something like this. Okay, so you have your 6 graphs drawn. What I want you to do now is take some time and tell me if you think each of these is a function, and you can just respond with a yes or no. I do expect to see these drawn when you turn in your paper tomorrow. And remember, we're going to use the vertical line test here. Okay, so go ahead and hit pause now, and then reconvene when you're ready to go over answers. Okay, number 1, did you think yes or no? Hopefully you came up with yes. It is a function, and the reason it is a function is because it does pass the vertical line test. And I'm not really good at drawing the straight dotted lines here. But anywhere I would draw a vertical, completely vertical dotted line, it's only going to cross in one place. So each input only has one output. All right, what about number 2? Number 2 is definitely no. Okay? Most places where I draw this vertical line, how many times is it going to cross? Here it's going to cross twice. Okay, so that means for whatever value this is right here, whatever that input value is, sometimes it spits out this y value and sometimes it spits out that y value, or I should say that f of x value. Okay, so that fails the vertical line test. All right, number 3, yes it is a function, or no it is not. Number 3 is also no. Okay, and you know, it is a function over here, at least it appears to be, right? Because it only crosses one time. But once you get into this section, that's when it fails the test. And it only has to fail the test once, okay? And then the whole thing is off. So for that one vertical line I just drew, that input had 3 separate outputs, okay? So that violates the vertical line test. All right, number 4 was pretty easy. That's a horizontal line, and that's definitely a yes. So horizontal lines are functions. Number 5, this is kind of a diagonal line, you know, one of these linear equations like y equals mx plus b type thing. This is also going to be a function. So that's a yes. Anywhere you draw that line, it's only going to cross one time. All right, what type of graph is number 6? Number 6 is very similar to number 1. Does anybody remember the name of those? Those are parabolas, and you probably worked a little bit with parabolas in middle school at some point. This is what happens when you have an x squared somewhere in the equation, okay? And wherever you draw these vertical lines, even though it looks like this parabola gets steep, like up in here and stuff, it still will only cross at one location. So parabolas, at least upward-facing parabolas like this one, would be a yes. Number 2, you kind of have a sideways one, and that's a no. But for numbers 1 and 6, it's definitely a yes. So yes, it is a function. Okay, so you had 4 functions and 2 non-functions. All right, very good. All right, let's move on to example 2. And kind of like example 1, we're going to do some drawing together. Okay, so you're going to have some more diagrams to draw. These won't involve coordinate planes. Let's see. We're going to do 3 drawings. So here's the first one. You can go ahead and write input and output. This is just going to be a diagram for a function. And sometimes you see these you know, as tables, and sometimes you just see these as diagrams. So I want this to not be unfamiliar to you. As a matter of fact, let's go ahead and do this twice. We'll come back and add in the details in a second. So your number 2 will also be one of these function diagrams where you have an input side and an output side. Anything I'm drawing right now, I want you to be drawing as well. I'll expect to see it on your homework. Okay, let's come back over to number 1. So here are your input values. And here are your output values. And now I'm going to draw some lines kind of showing you what the input-output relationship is. So for example, when I plug in a 3, it spits out a 7. That's what that red line indicates. So I'm going to do these for a couple more, and I just want you to think about what they might mean. And then kind of like last time below, just go ahead and draw a little blank. Don't write an answer now, but you're going to think about whether or not it is a function. If it is, you're going to write yes, and if it's not, you're going to write no. Okay, let's set up number 2. It's got some input values and some output values. Okay, and before I kind of leave you be, we're going to throw in a quick number 3 in here. This one is just going to be sort of a good old-fashioned input-output table. I'll put the input, output. Okay, and it looks like I need a blank for number 2 and a blank for number 3. Alright, so I want you to take some time after you've drawn these. Go ahead and discern, is it a function? If it is, write yes. If it's not, write no. and if not, be prepared to have some reasoning for why you think it's not a function. So go ahead and take as much time as you need. Answer now. Go ahead and hit pause, and then unpause when you're ready to go over answers. Okay, go ahead and hit pause now. All right, let's take a look at number 1. What did you come up with? Yes, it is a function, or no, it is not? Well, I'm pretty confident in you guys that you came up with no, it's not a function. My question is, why is this guy not a function? Okay, which number is kind of throwing it off for everybody else? And we're probably going to look at number 6 as the culprit there. Okay, when you plug in a 6, sometimes it spits out a 13, sometimes it spits out a 15. And I want you to start kind of thinking about this graphically, right? So on the coordinate plane, if you came over 6 and up 13, you might have a point right there. Well, 6, 15 is going to be a point right above it. Okay, is that going to pass the vertical line test? Definitely not. You're going to have 2 points that are aligned vertically. Whenever you go to try to draw a vertical line in between them, it's going to cross twice. So you know something like that is going to fail the vertical line test. So that's a visual for why these guys can't be considered functions. All right, let's take a look at number 2. Okay, this one might have been a little bit more confusing. Is it a function, yes or no? And the answer to this one, even this one's weird, the answer is yes. Okay, let's think about that. When you plug in a 5, it spits out a 4. Does it ever spit out anything else? No. Okay, when you plug in a 6, it spits out a 4. Does it ever spit out anything else? No. Each input has one and only one output. Okay, and I'll show you what this would look like perhaps on the coordinate plane. I'll draw here on the left. Okay, just so you can kind of visualize what this might be doing in terms of the vertical line test. 5, 4 might be a point right here, and 6, 4 might be a point right here next to it. Okay, 7, -1 might be a point down here, and 8, -1 might be a point beside it right here. Okay, and if you imagine, I have no idea what this graph might look like, but it could do something like this, right? You can get creative, right? It's possible. Is that going to pass the vertical line test? Absolutely. Okay, if I start drawing vertical lines, they're only going to cross at one point. Okay, so that is a function, definitely yes. All right, number 3, is it a function, yes or no? And the answer here, I think we all know, is no. Okay, this part is kind of messing it up. Sometimes the 3 spits out a 12, but other times the 3 spits out a 14. Okay, so that's one input with multiple outputs. That's going to be not a function. All right, very good. Let's move on to example 3. All right, function notation. I'm going to let you do this one on your own. Do copy this down. So write down the functions. F of x equals 3x minus 7, and g of x equals 1/2 x plus 2. Okay. We just use different letters for functions sometimes, so don't think that the G has any more meaning than the F. F, G, H, these are all popular letters that we assign to functions, and we just want to assign them different letters because they might do different things. That's it. Okay? All right, so for number 1, I want you to tell me what f of 10 would be, tell me what f of 4 would be, and tell me what f of 1 would be. And then on number 2, tell me what g of 2, g of 28, and g of 50 would be. And those are 2 different functions. They're 2 different problems. Okay? All right, do show your work for this as you're plugging in each individual number. I'll expect to see it tomorrow. Go ahead and try these on your own. Hit pause now, and then unpause when you're ready to go over answers. Okay, let's go ahead and see how you did. F of 10. When you plug in for f of 10, you're saying f of 10 equals 3 times 10 minus 7. So when you plug in a 10, what does that spit out? Well, it's 3 times 10 minus 7. That's going to be 30 minus 7, and we know that that's 23. So in this function, you plug in a 10, and it spits out a 23. Okay? And hopefully everyone got that. And that's what your work should look like. Okay, and then you would do individual work for each of these. So I won't go through all of them. F of 4, you're going to be plugging in a 4 for the x. So f of 4 is going to be 3 times 4 minus 7. It's going to be 12 minus 7, and that's just going to be 5. So it's just getting used to the notation. For f of 1, you're plugging in a 1 for x. So 3 times 1 minus 7, that's going to be 3 minus 7. So f of 1 is negative 4. Okay? And you can think of these as like ordered pairs, right? If you had to graph them. This guy here would be 10, 23. This guy here would be 4, 5. And this guy here would be 1, negative 4. All right? Let's go over to the g's. G of x equals 1/2 x plus 3. So we're halving some numbers. Halving, however you would say that. G of 2 is going to be 1/2 times 2 plus 3. All right. 1/2 times 2 is 1. So G of 2 is 1 plus 3. And 1 plus 3 is 4. So when you plug in a 2, this guy spits out a 4. Okay. G of 28 is going to be 1/2 times 28 plus 3. Half of 28 is 14. 14 plus 3 is 17. G of 50 is going to be 1/2 of 50 plus 3. 1/2 of 50 is 25 plus 3 is 28. All right, very good. Hopefully all of that made sense. Let's move on to the last example. And this one, I don't want to tell you how to do it. I want you to think about it and see if you can come up with it. It says find the slope of the graph of the linear function f. Okay, so we're talking about one function. Okay, we'll call that function f. And the only information that you know is that f of 3 equals a 7. So when you plug in a 3, it spits out a 7. And f of negative 1 equals negative 9. So take that information. I want to know what the slope of the graph is. Okay, don't give up. Try that on your own. Many different ways to do this. Let's see what kind of idea you come up with. Go ahead and hit pause now, and then don't give up. Unpause when you know the answer. Okay, well, I've been kind of hinting at this the whole time, and hopefully you've been listening to me. This is input-output, so you can think of these as, almost like having a t-chart here, right? When you plug in a 3, it spits out a 7. And when you plug in a negative 1, it spits out a negative 9. And, we usually call that input-output. Sometimes we call it x and y. Sometimes we call it x and f of x. Okay? Now, I like to think of these as ordered pairs. Personally, that's the way I'm going to go with this. Okay, so this guy would have the ordered pair 3, 7. Plug in a 3, it spits out a 7. This guy over here would have the ordered pair negative 1, negative 9. And notice that those two ordered pairs, those are 2 points. Okay, and you should remember how to find the slope of a line anytime you're given 2 points. Remember, we're going to use that slope formula, where this is x sub 1 and y sub 1, and this is our second x, x sub 2, and this is our second y, y sub 2. And this is something you have to just kind of commit to memory. Remember that slope is going to be the change in the y. So we subtract the y's to find that distance. That's your rise. Over the change in the x's. We subtract those x's to find your run. Okay? And you can just plug these in to find out what that slope number is going to be. Okay, so let me just set this up. Y sub 1 is 7. Y sub 2 is negative 9. X sub 1 is 3. And x sub 2 is negative 1. And notice how I kept the minus signs from the formula. And then I can simplify all this stuff. Okay, 7 minus negative 9 is going to be 7 plus 9. That's going to be 16. That's my rise. 3 minus negative 1 is 3 plus 1. That's 4. That's my run. Okay, so the slope is going to be 16 over 4, which reduces to 4. Okay, so my slope number is 4. All right, now let's back that up with some graphical knowledge. Okay, here's how you do a quick check. Okay, you draw a quick coordinate plane. All right, does my answer of 4 make sense? Well, let's plot these points, and you don't even have to do the tick marks, right? 3, 7 might be a point all the way up here. right? -1 comma -9 might be a point all the way down here. All right, when I connect these to make a graph, all right, does the graph back up what the slope is telling me? Okay, well, the slope of 4 is telling me that it's positive, it's going up the roller coaster, which this guy is. And does 4 indicate steep or gradual? Well, it's a number greater than 1, it indicates steep. And this guy over here is definitely pretty steep. So, you know, my visual there backs up my answer of 4, so I can feel a little bit more confident about that. All right, if you didn't get that one on your own, that's okay, but hopefully you understand the thinking behind it now, and you're better prepared to do the assignment. All right, good job with this lesson. It's our last lesson of the unit. Really important test coming up, so make sure that you study. All right, see you in class.